afternoon, everyone. So today we'll be talking about uh, the sensitivity analysis in the linear programming problem. So first of all, we'll study about the introduction of what you understand by sensitivity analysis. So sensitivity analysis is the study of sensitivity of the optimal solution of a problem due to discrete variations or changes in its parameters. The degree of sensitivity of the solution due to these variations can range from no change to all to a substantial change in the optimal solution of the given LP problem. Thus, in sensitivity analysis, we determine the range over which the LP model parameters can change without affecting the current optimal solution. For this, instead of resolving the entire problem as a new problem with new parameters, we may consider the original optimal solution as an initial solution for the purpose of knowing the ranges, both lower and upper, within which a parameter may assume a value. So this is primarily means that what we understand by sensitivity analysis. So what we do is when there is an optimal solution to the linear programming problem, we change certain parameters, we change certain constraints, we change certain objective functions. So based on that, we tend to know that how does my LP problem optimal solution or optimal solution is behaving to that change, right? So this is what we call as a sensitivity analysis, right? So there are different categories of parameter changes in the original LP model, which are discussed in this chapter. The first one is the profit per unit associated with both basic and non-basic decision variables. It coefficients in the objective function. That means that the cost and the profits that are involved in the objective function can be changed, right? The coefficients can be changed. If we are changing the coefficients in the objective function, then what will be my optimal solution? What will be my final answer, right? So next is availability of resources, right hand side of the constraints. That means the available constraints, and the available constraints are changed, right? What will be my final solution? What will it affect the optimal my optimal solution or not, right? If it is affecting my optimal solution, to what extent, right? The next one is consumption of resources per unit of decision variables. Coefficients of decision variables on the left hand side of the constraint. That means that when you are, changing or varying the resources that are available to the market, that are available to us, right? That means we are changing the decision variables according to that. What is the optimal solution, or what are the changes that can happen to that particular optimal solution or particular problem, right? The fourth one is addition of a new variable to the existing list of variables in LP problem. That means that when you are adding a new variable to the list of existing variables in LP problem, it contains that it shows that what will be my now, what will be my optimal solution, what is the change that I'll be getting, right? Addition of a new constraint, or it could be an addition of a new constraint to the original LP problem constraints. That means, for example, we have given the two constraints, right? For example, and if we add one new constraint to the problem, so what will be my optimal solution? Will it be the same, or will it increase? Will it be different? So I wanted to know that what will be my optimal solution. The first one, which we have already been discussing, is change in the objective function. So these are some of the learning objectives which you will uh, can go through using this slide, right? And which will you be learning after going through this video lecture, right? So I'm skipping this. So introduction, we have already discussed what are the options we have for checking the sensitivity of LP problem. We have discussed five cases, five things that can be used, that can be changed to obtain a sensitivity report, right? So the first one which we are trying to discuss is obviously the change in the objective function, right? Before that, we need to find out what is the role of sensitivity analysis of the optimal solution, right? So is the optimal solution sensitive to changes in input parameters? So I wanted to know that whether my solution which I've obtained using the simplex method or any other method, if you're talking about, right? So it is, if it is I mean sensitive to the input change parameters or not, changes in input parameters or not, right? The next one is possible reasons for asking this question will be parameter values used where only estimates. Parameter values were used only with best estimates. That means the parameter values which we have used are the best estimates for my particular solution or for my particular problem, LP problem, right? The next one is dynamic environment may cause changes in the solution because we are living in a very dynamic environment, so it can be, I mean, it can adapt to changes or not. Last one is what if analysis may provide economical and operational information, right? If there is a change in constraint, for example, in my objective function, so what will happen to my overall solution? Will it be economical or will it provide any operational information or not, right? So this is some things which we are going to discuss, which we are trying to discuss. So already we have discussed that the first one is sensitivity analysis of objective function coefficients, right? So the value of the objective function will change if the coefficient multiples a variable whose value is non-zero. The optimal solution will remain unchanged as long as an objective function coefficient lies within its range of optimality. If it's lying between the range of my optimality, the objective function, if it's lying between the range of optimality, the objective function, my optimal solution will not change, right? And if it's beyond that, my optimal solution obviously will change. There are no changes in any other input parameters. So we are assuming that there are no changes in other input parameters. That means the constraints, right? The optimal range for an objective coefficient is the range of values over which the current optimal solution will remain optimal. So this is the value at which my current optimal solution will remain optimal, or it's also called the range between which my optimal solution will remain unchanged or will not change. Right. The second case, which is also called change in availability of resources. So there are two cases in this. When slack variable is not available, not in the solution mix, that means that there is no slack variable in my solution, right? And the second case is when slack variable is there or is in the basis. And the third case is when changes in right hand side when constraints are mixed type, when surplus is not in the basis and when surplus variable is in the basis, right? When surplus is added to probably the problem, what will be my changes? So this is something which you have to probably check using different methods, different techniques, right? So the techniques which we are not going to discuss here will be discussed in the further lectures too, right? So the next case I would say is changes in my input output coefficients, right? For example, if we are changing the constraints, the coefficients of the constraints, or probably the availability of resources, we are changing those. So uh, what will be my optimal solution? So there are two cases in this changes in an input output coefficients. Change in coefficient when variable is a basic variable, right? Change in coefficient when variable is a non-basic variable. Okay. So when it's a non-basic variable, the only effect of such change will be on optimality condition, right? If there is a change in some of the non-basic variables, then there will be a change in my optimality. Otherwise, there will be no change in the optimality, right? If there is any change in, suppose in in a no change in a basic variable, basic, right? That conditions to maintain both feasibility and optimality of the current optimal solution, right? So in that case, probably my optimal solution will not change. That means that if there is no change in basic variable, there is no change in the optimal conditions or optimal solution of the problem, right? So the fourth one is when you add a new constraint, right? The decision maker may recall that a particular resource constraint was overlooked in the model. Probably when you were probably formulating a linear programming problem, you overlooked it. You missed it, right? Perhaps you may desire to know the effect of adding a new resource to enhance the objective function value. Addition of a constraint is the existing in the existing constraints will cause a simultaneous change in the objective function coefficients as well as coefficients of the corresponding non-basic variable. Thus, it will affect only the optimality of the problem. This means that the new variable should enter into the basis only if it improves the value of the objective function. It means that if you are adding a new constraint, new variable, right, it should only add value, increase the objective function or probably improve the objective function, I would say, right? If it's not adding any value to the objective function, there is no point of adding the new constraint, right? The fifth constraint or the fifth case, I would say, is this only, right? This is the last case probably when you add a new constraint to the particular problem, to the particular linear programming problem. So this is how you measure the sensitivity of the report. So there are certain softwares that are available in the market. One of them is obviously, I guess, right? The most important, the most highly used is the Microsoft Excel solver tool, right, which helps you to find the sensitivity of the report or sensitivity of the optimal solution. Thank you so much. We'll be discussing more about this. Thank you in the coming lectures.